In quantum mechanics, what does it mean to observe a particle? Well, this is more complicated than you might think. First thing you need to know is that particles are waves in a quantum field. And those waves are essentially mapping out the probability that it will interact with another wave in the quantum field. Now, the particle is everywhere the wave is, essentially. And when two waves interact, there's this big overlapping space between them that is essentially where they could interact. And where they do interact, the one space where they interact, that is usually where we say it is, where a particle is. Now here's the trick. For anything to happen in the universe, it requires waves interacting. Which means that if we have a particle, like a photon or an electron, we can't ever tell anything about it without having another particle interact with it. Like even if we were to see it, that is a photon bouncing off it and going into our eyeballs. If we were to detect these particles on an ultra-small quantum scale, we would still need mass or energy, particles, waves in the quantum field, to interact with them in some way. And so observation is essentially that, interacting with another wave in the quantum field. It has nothing to do with us seeing it or consciousness or any of that other quantum woo bullshit. It's just that when one quantum wave interacts with another quantum wave, we can see the interaction. And if you were struggling with the uncertainty principle, that might help you out. Because again, a particle is actually a wave in a quantum field. It's all over the place. But when it interacts with another wave in the quantum field, it only interacts in one place. So when we say things act like waves and particles at the same time, when they're not interacting, they're just kinda there as waveform. But when they are interacting, you can zero in on the one place they're interacting and treat them like a particle, a single point. And tangentially, this is why quantum teleportation isn't as mystic as people make it out to seem, but if you want me to explain quantum teleportation and quantum tunneling, that'll have to be another video.